Today we're going to explain to you the thread efficiency lab. So the theory behind threads, in this case, we're checking the efficiency and the coefficient of friction for the transmission of force from linear to rotational or vice versa. We'll test 3 different materials. We've got red bronze, nylotron, and then gray cast iron. And each of those should have a different coefficient of friction. The second variable we will be testing is the thread pitch angle. So as that angle varies, it will change the efficiency of your translation from linear to rotational motion. And then the third variable that we will check is the effect of axial loading on the device. So for the setup, you have your nuts, which will screw onto the threaded piece, and you'll mount them into the device, tighten it up, and wind the string around the disc on the top. This part of the lab. So you attach your force gauge, and as you pull, as you can see, it will be raising the whole system here, and you record your force value, and from that you can calculate the friction and efficiency. So in this case it would be roughly 1 Newton. You repeat that with the 2 different pitch angles and all 3 materials, and finally you would repeat it again with the axial load on top. So one of the variables we test in this lab experiment is the pitch angle of the threads. And actually, if you get close, you can see the difference. Over here we've got the, as it's called, TR30-12, and you can tell it's what I would describe as steeper, the rotations, whereas over here on the TR30-6, it's flatter, so you have to make more rotations to get the same linear movement. So the components for this lab are a nylotron threaded nut, a red bronze threaded nut, 2 of the gray cast iron threaded nuts, 1 for each pitch angle that we will be testing. You also have your 2 weights that will be added as an axial load, and the stand, which the threads will be mounted within. Finally, you have the force gauge. This particular gauge, your force will be measured in newtons. The increments on this scale are 0.05 newtons.